We're now going to go through our third real-world example, and we're going to build a bit of a bigger application. We're going to have three CDK projects. We're going to have a VPC project. Tell you what, let me stick VPC after that. We're going to have a ping service project, and we're going to have a pong service project. And as the names would imply, the services will talk back and forth between one another. And the VPC project is going to produce a VPC, which is going to be referenced in these two projects. Because we're going to make a very similar service within these two projects, we're going to also make a service construct. Make that a little bit smaller. And we're going to consume that service construct in both of the two projects building services. All right, let's start making it. Let's pop to this empty VPC project I've got, and at the moment all we have is a bin folder with the account and region being read from environment variables. So let's create a ping pong VPC stack and start just how we do normally with the class extending stack, and then the constructor has three arguments: the scope we're attaching it to, whoops, the logical ID, and some properties, and let's just call these stack props. We'll pop them, pass those, to the parent constructor, and I'm just going to turn on the prettier support in the editor while we are here. That's a bit better. And then let's make a VPC. So we're going to use the level 2 VPC construct, and that's got tons and tons of options for us and does a huge amount. So let's have a look at the VPC props, see what we're asked to provide. The first setting is the IP addresses we would like on our VPC. So let's have a look at that type. And you can see that we've got an interface here that we can have filled out for us by another class. And there's a helper class above with a CIDR method to build one of those objects, or build an object satisfying that interface. So let's add that in first. Whoops. And say IP addresses dot CIDR, and then let's just have a 10.10.10.10.10.00016. Lovely. All right. We don't need the CIDR property because that's deprecated and we've already used IP addresses. We would like to have enable DNS host names configured on our VPC. I don't see why we would have that turned off really. And DNS support as well, we also want that on, which is required for the setting above it. I'm just going to see if I can pick up the prettier config for the editor. There we go. Lovely. What else have we got on our VPC? So we've done DNS support. Default instance tenancy we're not really worried about because we're just going to have the default tenancy or shared tenancy. And max availability zones, let's go for 3. Lovely. We will leave reserved out. We're not going to specify them manually because we've specified max AZs. And then we've got NAT instances. Just bear in mind that if you're following along with this, we're going to create NAT instances and there'll be a cost associated with that. So it's just something to think about. You make sure you tear it down when you're done. Okay, and I think we are happy with all the rest of them being defaults. Let's see what we get if we synthesize this. So let's do CDK Course, synthesize it into a file. Whoops, have I put the wrong file name in there? Let's just make sure if I do a quick npm install. And I'll wipe this node modules and redo it. Okay, there we go. Got a more sensible error message. So let's go and initialize this stack in our bin folder. We'll attach it to the app. We'll call it ping pong VPC stack, and then we'll pass in the account and region we have looked up above. Okay. And there we go. We've got our template synthesized. So we have a VPC. We've got a few subnets. So there's public 1, public 2, public 3, and we can click through these and we've got private 1, and then I assume we'll have private 2 and private 3 for the other 2 availability zones. And then there's a ton of infrastructure to support these subnets. So we've got the route tables, for example. So here's a subnet. here we go, here's a route table for it, and there's a route table to subnet association, and you've got routes for things like the internet through the internet gateway. The private ones will rely on a NAT gateway, so the NAT gateways have to be created in the public subnet in the same availability zone, and so on and so forth. So we have a complete VPC setup for us just from that tiny bit of config that we've provided inside of our stack here. Now we might be thinking, well, if the VPC is going to exist in this project, how are we going to reference it in the other project? And if we click into VPC and we look for from lookup, which is a static method, you can see that we can look it up by a number of options, one of them being tags. So let's set some tags on this end where we're creating the VPC, and then we can use those tags on the other end when we are consuming the VPC. So let's pop it into a variable, and we can do tags of VPC, and we can say that the service is, or I'll tell you what, let's should we go with service? Let's go with project, and this is the ping pong project. All right, let's give it a deploy. All right, with that deployed, let's pop over to one of our services. We'll start with the ping service. So I'm going to do a very similar thing in this project. I'll just clear the node modules and get that installed fresh. And I'll make sure we're using the prettier config. Lovely, and let's make a new stack. Now we could just start throwing infrastructure into our stack here, but the best thing to do is for us to think about how we can make this reusable. And in the case of the service that we're doing at the moment for this, this little example, this lesson, it's going to be almost identical between the two services, between the ping service and the pong service. And you might be thinking, well, do we go straight to building a construct then? But it can get a little bit slow if we're putting it to a separate package and trying to iterate that way. So one thing we could consider is making it a construct within our one project for now, getting it working and getting it happy, and then once it's ready, we can bring it over into its own separate package, and then we can install it in this project and install it in our other project. So let's do that. Let's see what we need for an ECS service. So I'm going to create a new private method called create service. We'll do a new service. And oops, that is from the wrong project. Let's go with a Fargate service because we're definitely going to deploy this into Fargate. So we need an ID. We'll give it a empty set of props and see what we have to provide. So we have to specify task definition and cluster. So let's pop those in. And cluster is an I cluster, and task definition is a task definition. So we might not want to make the cluster between, in both of our services. We might want to share the same cluster. So let's see how we could look up the existing one if we had one already. So we could say const cluster equals cluster with the capital C for the class. And then let's have a look at what methods we've got on here. So we can say from cluster attributes, or we can do from cluster ARN, but that's missing some of these properties. Let's see if we can get away with the version that's using the cluster ARN to begin with. So let's pop that in, and then we're going to say attach it to the current scope. We'll just call it cluster, and then we need to provide it with the, oh sorry, I've used the wrong one, from cluster ARN, there we go. And then we need to provide it with the cluster ARN. So where's that going to come from? How are we going to get that cluster ARN into this value here? Well, what we could do is we could pop to our VPC project. We could make a new cluster. We've got to make sure we import the right one from ECS, not EKS. Do we need any parameters? No, we're all good. And let's pop that into a variable. And then we can make a new string parameter, which is a SSM parameter, a systems manager parameter store parameter. There you go, rolls off the tongue. And we could say this is the cluster ARN. And then we could pop that into the value and name here. So let's give it a name of ping pong / cluster / ARN, and we'll give it a string value, which is going to be cluster dot cluster ARN. Okie dokie. Let's deploy this project again. After filming the content for this lesson, I realised I'd made a mistake in the setup of the cluster, and actually it should have had the VPC passed in. So if you're following along at home, make sure you pass the VPC in at this step. Alright, and with that done, if we pop into the AWS console, we go to Systems Manager, and we look in Parameter Store. Then we have a cluster ARN in our SSM parameter. So let's pop over to the ping service that we were working on, and where we've got the cluster ARN here, we're going to do a lookup. So we want string parameter, and then we've got quite a few methods to choose from here, but we would like the lookup version, which is going to fetch it and put it into the cdk.context.json. So we have to attach that to a construct or somewhere in the scope, which is going to be this. And then we've got the name, which is ping-pong /VPC/ARN. And then we can use that cluster inside of our service definition. The next thing we need is a task definition. So let's go and have a look at that class and see what it wants. So we can look one up, but before we're actually going to make one, I think that would make the most sense. And there's a ton of different options here. And I think there is a Fargate task definition class that we can use. Yes, there is. Lovely, that should have some niceties set to it. So let's have that passed into this method when we're making the service. Pop that in there, give it the right type, and then in our constructor. So actually we haven't put it into the constructor yet, so let's do another method for create task definition. That's going to return a task definition, whoops. And then let's do that. So we're going to return a new Fargate task definition, attach it to the current scope. We'll just call it task definition. And then we need some properties. Oh, sorry, I meant to put Fargate task definition, not Fargate service. There we are. All right, so no properties required by TypeScript. Let's have a look at our options. So the first one is CPU, and we're going to use a teeny tiny number for a teeny tiny container. So let's go with 256. Next one is memory, which we have to, well, we don't have to choose 512, we could have slightly bigger, but I think we'll go with 512 because we want a teeny tiny container. Not too bothered about changing the default ephemeral storage setting. That's fine for us, we're not really going to use the storage. And then runtime platform, let's have a look at what our options are there. Yeah, we can choose an architecture and choose an operating system family. So we're on Linux, which will be the default. And I think by default will be on x86 as a CPU platform, but that's fine again as well. Okay, that's it for those properties. What about any parent classes? So common task definition props. We can specify a family, which gives it a name, but we'll just use the auto-generated name. And then there's an execution role and a task role, and we'll have to see whether these are created for us or whether we'll have to manually make them, say if we want to give our container some permissions. We're not interested in a proxy configuration, and we're definitely not going to attach any other volumes or other bits and pieces. Okay, so that is the last of those properties. I'll tell you what, actually, while we're here, let's pop this into a variable, and then we can return the variable, because I think we're going to have to use that to add a container. Okay, there we go. There's where we can add in a container. So let's do that. Let's set the ID to app and see what options we're required to provide here. So we have to give it an image. An image is of type container image. And then we can do that from a Docker image asset, which is what we're going to go for. So let's give that an import. And then we want a new Docker image asset. Whoops. And then what are we asked to provide for this? So we've got scope, an ID, and some props. So let's add that in there. And then see what props we're expected to provide, and then we want a directory. So let's import the path module. I'm getting all my speech marks in the wrong place today. There we go, and we're going to join together the path here. So we're going to have the current directory, and where are we? We're in the lib folder, aren't we? And then let's make a new folder called containers, and in there we'll have one for the ping service. Okay, and then let's go and make that now, and we're going to have to make a Docker file for our containerized service. And then let's go and grab a Node.js base image. And we'll go for Node 18, which at the time of recording I think is still the LTS. And what underlying operating system should we go for? I think we will go with Bookworm. Actually, that's the default if we want a slim image. So let's go with LTS slim. So from node and then our tag. And then we need to copy in some files here. So we would like some kind of index.js. Let's copy that into the container. And then we want to do an npm install. We'll do an npm CI though, because we don't expect to have any differences between the lock file and our main package.json. And then we're going to have to see if we need to set a command for this. I wonder what that is by default. Don't know if they've got a little version we can use here as an example. Probably not. Okie dokie, let's say the command is going to be index.js. All right, let's create a package.json. And we'll give it a name. Let's say this is the ping service. And then for some dependencies, we are going to have express. And just take the latest version there. And then let's go into that folder and let's build our container to try it out. So let's pop into lib, containers, ping service. And let's do an npm install actually first, just to make sure we've got a package lock. Lovely. I'm going to add a docker ignore file so we can ignore those node modules because we want the version that's in the container. All right, let's give it a try. We'll do docker build, set a tag name, call it as ping service and the current folder. Lovely. Let's see if our ping service runs. Let's do docker run. We'll use rm because we want it to be closed down or deleted after we're finished with it. We'll have -it so that we can do things like Control-C to get terminal emulation. Then we'll have the tag name, which is going to be ping service. And let's see what happens. Okay, well it ran, so that's good. It didn't have any errors. Let's make an app. So let's import Express. We're not going to mess about with any kind of translation, compilation, etc. So we're just going to use the common JS syntax here. And then we can do app equals Express. We would like to do app.listen. And we can say console.log app is running. I'll tell you what, we should specify a port here. Let's go with port 3000. Okay, and then I'm just going to add a health check endpoint on /healthz. And all we're going to do for this is just send back a successful response. I'll tell you what, actually, whoops, sorry, that should be status. Status.json, and then let's do OK, true. We're not actually using our res argument there, so we could, oops, there we go, I've named them correctly. Not actually using the rec argument, sorry, so I'll just stick an underscore in front of that as a convention. And what's this saying here? Yeah, this is just a lint for it using the require rather than import, but this is a regular old common JS file, so that's fine for us. And we can do another endpoint as well. Same thing again, we're not going to use rec. And we could do res.status 200, and we can send some JSON, and we can say, we'll give it hello world, why not? Okay, let's build our container again, and let's give it a run. And it says app is running, fantastic. One last thing we will do while we are here is, so we're not getting the Control-C pass through there and killing it, and that's an issue with the interaction of Docker and Node. When we do it in Fargate, we can set an option to make sure that it quits the container properly, but I think for this one, we're going to do a Docker PS and then a Docker stop just to get that to shut down. Whoops, I've managed to paste in some stuff there. Give that a little while to go. So we've made a dummy service. Let's add an expose into the Docker file for the port that we're using for the service. And we've got an asset set up to build that image, and then we're going to use it inside of a task definition, and we've set some basic parameters for Fargate. So let's start putting things together. So we'll make a variable for the task definition, and we'll build that. And then we will do this .create service, and we'll pass in that task definition. Lovely. And let's see how we get on. Let's see if everything works. So I'm just going to pop back to the root of the project, set my AWS credentials up, and then do a deploy. Oops, I did it again. Let's go back to the bin folder and let's initialize our ping service stack, attach it to the app. We'll just call it ping service stack, and we will specify the account and region. Okie dokie, let's give that another deploy. So we're getting an error there, and this is a bit of an interesting one because we're using a lookup, so you would expect to have the value straight away. But when we're using a context provider or when we're using a lookup, the first time that everything runs, the first time we go to synthesis, it will actually give a dummy value to the rest of the code base, which is kind of hard to deal with, kind of hard to check for. We could put in a little if statement to catch this, but hopefully the CDK context JSON has been populated. So, okay, I don't think we got that far, did we? No, okay. Let's clear that out because it's been used before. And let's pop to our service, find where we've got the find where we've got the lookup, which is in the service, isn't it, here for the cluster. And then we can say if cluster, oh, sorry, let's, we've got to split this parameter lookup out so we can get the arm here, pop it into a variable. Okay, then we'll provide that later. And then we're going to say if the cluster arm dot starts with dummy value, then we are going to return, and we'll stick a little note on this and say that until the context lookup has been completed for the first time, we have a dummy value we can't use in the cluster.fromClusterArm method. So we'll give that another run, and then it will run through actually a couple of times. The first time without the value and the second time with the value. Oh, we are missing our value. Oops, sorry, I put VPC ARN rather than cluster ARN. Okay, so we're getting an error here where it's trying to use the VPC parameter in our cluster object, but we don't have it available because of the method we've used to go and grab it. So in this case, we're going to have to use from cluster attributes instead. And then let's see what we are expected to provide. So we have to specify the cluster name, and then we have to specify the VPC. So let's do that. So let's do the cluster name, and we're going to change this cluster ARN parameter to be cluster name instead. We'll change the parameter name we're looking up to name, and we'll change the bits and pieces here. Let's change that documentation as well, or that comment as well. All right, and then we'll use the cluster name from our SSM parameter, and for the VPC, we're going to do a lookup. So we can do VPC.fromLookup. We'll have to use the current scope. We can use the VPC there, and then we are looking it up by tags. So let's go and have a look at what tags did we set on our VPC in the other project. We used project and ping pong. Okay, so we'll pop back here. We will have project going to ping pong, like so. And then that should give us more settings on the cluster. Not everything, but more settings. So we're going to have to deploy the new SSM parameter. And I'm actually going to leave the existing one in place because I don't see why not. Call the new one cluster name. Set that there. And there we go, cluster name. Give it a deploy. All right. So we've got a new parameter set. Let's go to the ping service and let's give that a deploy and see how far we get. You can see here that it's building our Docker container, and that's happening automatically. We don't have to worry about how we build it with the commands or steps required. So the deployment succeeded, but it took a very, very long time, which to me would indicate that something went wrong. And I've just been to have a look in the console here, and we've got a series of tasks that are failing to start. So here's an example. It says essential container in task exited. And then here's our app container, and it says stopped exit code 1. So we tried our container locally, and that seemed to work fine, but it appears that when we run it in Fargate, something is going wrong. And that might be because on my local machine here, I'm running in ARM, and on, I should say, Fargate, we're running in x86. So let's try changing that over to the right architecture. So I think we had that as an option on maybe not the task definition, but perhaps a service. Let's go and have a look, see where that option's gone to. So for our service, we've got a platform version and base service options. Okay, nothing to do with the CPU from what I can tell. So let's go and have a look at the task definition. Aha, here we are. So we have runtime platform and we can choose a CPU architecture. So let's do that. Let me close a few of these bits down. Pop back to the ping service. And then in the task definition here, we will choose the runtime platform, and in CPU architecture, we will choose, should be an option here. There we go. Or is there an enum for this? Yeah, there we go. My IntelliSense is just playing up at the moment. Oops. Cool, so we'll try again on ARM. Okay, so a bit quicker this time. Let's pop into ECS again and let's see what happened. And we now have one running container. Awesome. So that's a nice example of what happens when you use one architecture in one place and one architecture in another. Let's try and add in a few more settings while we're here. So earlier we talked about the interaction between Docker and the node container and it not getting killed properly when we use Control-C. So let's add the Linux parameters here and see what options we've got for that. And then there's a few, so, oh, it's a class, sorry. Let's do a new Linux parameters and give that an import. And what would you like? So 2, 3 arguments, so we want a scope, an ID and some props. And then in the props, can we turn on the init process? Yes, we can. Lovely. That'll interface between Docker and Node and get that working properly. The other thing we will do is set up some logging. So let's do a log driver with AWS's logs, which is just CloudWatch. And what properties do we have to provide? So stream prefix. Let's just go with ECS. I'll check the documentation if there's any format that has to be in. Yeah, just ECS will be fine. Lovely. Okay, let's give that another deploy. All right, let's go and check out the service. So let's give that a refresh. Go and have a look at our service. We can find the running task. Oops, there we go. Here it is. And then this time in logs, we have app is running. Fantastic. But we need to be able to connect to our application. So let's do some networking. I'm going to pop to task definition and let's see if the networking stuff is at this level or at the container level. Okay, it's at the container level, so let's have a look in there. And we need some port mappings, that sounds good. So we've got a container port, and then I think for Fargate we don't specify a host port. And we'd like the ECS Service Connect functionality, so we'll set a name. Okie dokie. So let's do some port mappings. We're going to have one. The container port is going to be 3000. The name will be app. And the protocol is, sorry, the app protocol will be HTTP. Oh, for some reason that's lowercase. Let's set the protocol as well. I don't know whether we want that TCP or UDP value, to be honest. I think we're fine with the default, which should be TCP, but we'll pop it in there anyway. And let's give that a deploy. All right, with that done, we are really shaping up our service.